So for our group, the next new thing is something that we've been excited to start thinking about and putting together a team to explore in more detail. We have 4 cameras that are flying on the test satellite, but it turns out that we had to build a flight spare, and the flight spare is quite a nice camera, just as good as the ones that we're actually flying. So one idea that we've been working with is to put this camera along with another relatively small telescope. The telescope itself would be about 45 centimeters in diameter, which is about the span that I'm showing with my hands, and put these into a satellite that we would position at a different location in the solar system. TESS is in this orbit that takes it out to about 400,000 kilometers away from Earth. There's another location in the Earth's orbit that it's called a Lagrangian point. Lagrange was a mathematician who worked out orbits and properties of orbits in the 1700s, and this point is the 5th point that he was able to actually establish. So it's called Earth Sun L5. This location actually forms an equilateral right triangle with the Earth, the Sun, and this location. So that means it's 150 million kilometers away from Earth, and it's also 150 million kilometers away from the Sun. But the thing that's really interesting about this point is as it's distant, but why would you want to go there? The reason that you would want to go there is that it's the darkest place that you could be in the solar system. And what that means is that there are no sources, there are no bright planets nearby. You're well away from the sun. The sun, of course, would illuminate the satellite, but without other reflecting surfaces, you could always put a sunshade in place, and then that would provide the darkest place from which to view. In fact, the sky there is about it's about 1 million times, between 100,000 and 1 million times darker than it is in the TESS orbit. Okay, so why is this interesting? This means that this is interesting not only because it's dark, and dark skies are always important for astronomers, but the other thing that it provides is that with the baseline between a small satellite at that location and TESS, you can look at objects that have very short durations and basically do what physicists call coincidence measurements. If it's a flash from a supernova or some other event like that in the sky that lasts for a relatively brief time, and it's very faint, if you see it in 2 satellites at the same time, you know it's real. If you see a flash of some sort from just one satellite, it could be some sort of an instrumental anomaly or a cosmic ray or some event like that. The other thing that this gives you is it gives you a chance to basically do what astronomers call a parallax measurement for the outer solar system. And that is, if you think about what's happening as the Earth revolves around the Sun in 1 year's time, this location with this small satellite will also take a year to move around. But the difference is there's going to be a baseline between the two of 150 million kilometers. So if you look to the outer solar system, that means that you can actually carefully map out all of what are called trans-Neptunian objects, which are remnants from the formation of the solar system, of which we've discovered a few hundred, but we know that there are thousands of these objects that are out there, and what their composition is, and their size distribution, a lot of these things we have no idea. But more to the point, you can also look even further than those objects, which are typically a few hundred to about 1,000 times the distance from the Earth to the Sun. You can really look out 10,000 times further than that to the outer solar system. And if you do that, you can see what we refer to as the Oort cloud, which is the realm of planets, or sorry, the realm of comets, from which they come, and you can map out that area as well, or at least the inner portion of it. So those are the two of the scientific areas that this satellite would allow us to operate with. And the satellite would be significantly smaller than TESS, and so that's the idea that we're working on currently.